Hello, ladies and gentlemen, boys and girls. My name is xOctoManx, and this is a tutorial about how to measure things in Unity. What I want to show you in this tutorial is how to create your own measurement tool, which you can actually simply create with some simple tools actually, and with at least Unity 4.6 and over. This tool is going to work in 5.6, which where I'm creating this one. I can also show you how this is working in 2K18. Basically, everything is the same. In this tool is also working in 2K17 and so on and so forth, like everything up over 4.6. Since we are using the canvas system for the text in the middle over here, so we are going to use the canvas system for that. So how does the tool work? Basically, we can just drag around these little arrows in here, and this number will automatically update and center in between all of that. Center in between both arrows in here. We're gonna write a small function for putting this one into the center. Also, as you can see, I'm not in play mode. This is all live. This is like on runtime basically, or in editor time here. We're gonna tint our arrows to any color we like. We can make them red or green or blue, whatever. We can also tint the text to whatever we like and please as well. We can make it gray if we like to. And we can increase the scale of the little arrows in here if we have to do it. For example, when it is too small or almost invisible, whatever. Same for the text. We can also scale the text up and down by these little slider in here. And that's basically everything we're going to do here. We can also later on rotate these angles, for example, or these arrows. For example, when our tool is going to sit over here in the center, we can rotate it by 90 degrees. So we can also say something like top to bottom or something like this. And when we are done with all of that, we can also, of course, let me just switch that back to black so we can see it better. We can also take this measurement tool and measure top to bottom by just simply rotating this one by 90 degrees up to down. Just make this little arrows a bit smaller, and then you're good to go. I'm gonna go to isometric view over here, take one of my arrows, in this case the left arrow, and just move things around. As you can see, it overlaps a bit, but once again, for demonstration purposes in the total runtime or in total later on when you're going to a client or whatever you're gonna need to have this tool for, especially for presentation things. As you can see, the height of a cube in the base, when this is a scale of 1 in the y-axis, we're gonna see that we have 1 meter. To see this or to visualize that, once again, we can scale down the arrows so we can see this one better. Once again, we go to isometric right, and of course, once again, we can scale down the text by some numbers over here so it's fitting better at all. Also, you can move this complete tool just next to whatever you want to, like in this case, so it's not going to be that far away as a distance. So, and it looks better, like it has to be there. Okay, and that's what we're gonna do and create and start to create in just a second. Okay, first off, I want to show you how we create, or I created those arrows. Basically, I just created some, as you can see, triangles over here. I can always go and switch to sprite to the UI and set this one to multiple, since there are multiple graphics on my little graphic over here. And I open up the sprite editor and apply the changes, of course, to it. So what I want to make sure is that this little arrow in here, its pivot is not going to be in the center as it usually is when you drag around over here or when you start over. This pivot is going to be in the center. What you want to make sure is that you use a custom pivot over here. So you basically move it to the right a bit so you can see this pivot needs to be on the corner, on the front of our little arrow spike or arrow spike over here. So it's going to be 1 to the right and 0.5 from top to bottom. So it's going to be 100% on that. Same for the other one. In this case, it's on X 0 and on Y 0.5. So make sure you have that. And if you don't have the slice, of course, you can slice it automatically here like so. You just press slice. As you can see, now everything is set up. And then we're good to go. Once again, we take the pivot. We say it is going to be here top right. It's not, maybe it's just right. So, and this one is going to be left. So this is the easiest one over here. Apply the changes and we are good to go. So now we have 3 arrows over here. We can also rename those arrows by once again entering the sprite editor. And as you can see, this one is going to be arrow right. So I just give it an R over here, and this one is going to be arrow left. So it's pointing to the left, and we are good to go with that. So we can simply modify that, or actually give that the correct position. So the next one, what we want to do is we want to create an empty game object, and I just call this measure tool. Since we are creating a tool or a system for a tool, whatever, we want to make sure that we reset this one to 0, 0, 0. So we are good to go and everything is fine. I go to perspective mode instead of isometric mode, since currently it doesn't actually really matter. What we now want to do is we want to implement our 2 arrows so we see what we're going to do over here. So we take the left arrow and bring this here. And we're going to take the right arrow and bring this in the scene as well. As you can see from camera view, they are rather big. So what we need to do is we need to scale these things down. And also we want to make sure that we position them correctly already within the measurement tool. So what we take is L and R arrows and put them as childs of our measure tool. Since now we can position them correctly if we have to, and we can scale them directly inside the measurement tool. So we take them both, and for example, like the R and the L one, and we go to scale and scale these down. As you can see, they are scaling from the spike, from the top of the arrow instead of the center, and that's what we want. Since later on we don't want to rearrange this particular pivot point, since this is our length or our measurement point actually. So what I do now is I move this arrow, the left arrow, to the left. Somehow I'm looking from the right axis. So I move this one to the left and the other one to the right. So this is the right arrow, this is the left arrow. When you are not sure what is the correct direction of these, if it is really the right or the left one, we can always see the z-axis is always pointing away from you. Then everything is good to go. Since the z-axis is going to be pointing forward, also pointing forward from the main camera, as you can see over here. So this is the correct, at the moment, the correct way to see how they are actually represented. Okay, so what we now need to do is we need some functionality for our measurement tool. So we need a script. Also, we need a text element which is showing us all of this information. So let's create the canvas first. So we go to, directly a text, so we go into the drop down UI text, and what we want to do is we want to take this particular canvas and make this one not screen space overlay, we want to make this world space, meaning we can now freely position this into the world. So what I give it at first is a 1:1 height and width, so we are not going to have trouble with the size. Then we go to 0, 0, so it will be automatically here with a size of 1. So the next thing is now we want to position the text also at 0, 0, meaning it is going to be positioned inside the canvas or the center of the canvas, since this is child of the canvas. So, and what we now want to do is we want to make this canvas child of the measurement tool. Next problem is our text field over here is just too huge, I would say. And actually, no, it's not huge. It was okay for the size. Let me do it like this, but I didn't center it over here. So there we go. And now this is centered, but as you can see, it's rather huge, what you can see over here. And we can probably make this one a bit smaller. As you can see, our text field and our text itself is rather big. So at first I center this one into the in both, and I go and decrease the height to maybe 50 or even smaller. No, smaller is bad, so 50 should be fine for the moment. So, and 50 is bad as well. So I keep it maybe 50 and 100. It actually doesn't matter, since what we now do is we take this height or this size and we now want to scale this down. Also, I want to make sure that I use a bold text so I can see it better. Can also already tint this one black so I can see in the camera later on what the quality of the text is going to be. You can also use the new text mesh, I guess, or text, or what is it called? I don't know. if you like to. So what I now do is I scale down the text. Do not change the font size. Scale down the text. Why is that so? Because the font size is representing the text quality. But when we're scaling stuff down, the text quality stays the same. As you can see, now everything is still nicely readable. So what we do is we scale this one down. We just remember this number is 0.02, something around there, and it's still good to see. So instead of later on changing the font size, we just change the scale of our text box, or of our placeholder of the box. We keep the width and height. We can also play around with these if we need to, but actually I wouldn't. And in here, there's just later on going to be the numbers and the meter sign actually. Okay, so with everything set up, once again, I can set this one to 0.02 on all three axes. So 0.02 here, 0.02 here, 0.02 here. Even if that is not really affected, I just want to keep them at first, organized and simple and also easily readable. Okay, so the next one is we gonna have to write some code since we want to use our tool anyhow, since we have all the elements we just need for that. So what I do is I create a new C# script. You can create a script folder for that if you like and have to. And I call this one just measure. So with that measure, or this measure script will be sitting on the measurement tool as because this is the parent object of everything, so we can connect all the childs to the script, create a prefab out of the measure tool, and do not lose the connection to all the subfolder or subparts over here, since we can easily do that. So let's open this one up in MonoDevelop or Visual Studio. And once it has loaded, we can actually start to put in all the necessary data. Necessary data in this case is we don't need a start and update over here, since we don't have to update this in runtime or anything. We just want to have this in the editor, set it up, and then everything is fine. So what we need is, of course, we need two game objects of type game object, but for the left arrow and the right arrow. So we can say public game object, and we now say arrow left. We can also say arrow L with a big L. And we can also do the same for public game object arrow right or arrow R. So the next one is we want to have a scale for the arrow. So since we are able, or we want to be able to scale stuff down, it's going to be of type float, since it is going to be a point number or a common number. So it's going to be arrow scale. And we can set this one to maybe just as a base number to 0.15f. So the next one is we need an arrow angle when we want to do the rotation, as I showed you in the preview. So we say arrow angle. And we can set this one easily to 0 since we don't have anything in the start. Next one is we need a text field. So a public text. And the problem with that is we don't have the necessary data, so we need to make use of using Unity engine .ui namespace. This namespace is making use of text and image components and stuff like that based on the Canvas system. In this case, the text element is what we need, so we say text field. So we need this text field to be filled later on automatically by the number from whatever we need to calculate. This arrow angle, of course, is of type float as well. That's why it's red underlined over here. Okay, so the next one is we need some colors. So for our arrow, for example, we can also say we want to have a public color, and we can take color or color 32. Actually, it doesn't really matter. So, and we call it maybe at first arrow color, and then we can also do the same for the text. So we have a public. At first, we're gonna go, of course, with the scale. So public float text scale is equal to, and then we set this base to 0.02f as a base. And then we're going to take the color. So public color text color. So, and this text color, we don't need to fill on data because it starts with black. Usually, that's basically it. So now we need something else, which is at first we want to have a connection to the canvas. So we can position the canvas in between the arrows. So we say public game object canvas. So this is going to be our text canvas or whatever. You can name it once again however you like. And we need a distance. So the distance we want to measure, or we are measuring. And to keep everything organized, we can also later on create some fields, headers, and all this range sliders. I'm gonna show you what I mean by that once we are at the point of doing so. So how can we change or visualize things in the editor? Or in the editor itself. So I'm gonna make use of the function onDrawGizmos. So this onDrawGizmos runs the whole time. Meanwhile, we are inside the editor. And that's what we're gonna need. So every time we are doing something in the editor, onDrawGizmos will automatically make sure that everything is changing by and updating. Whenever we are changing the distance, the text gets updated to whatever we set it to, and so on and so forth. So, but before we can do that, we of course need another function, and this is our own function at first, where we want to measure stuff. So, or measure your stuff, measure my stuff. We want to measure stuff. It doesn't matter what we want to measure, we just want to measure stuff. And what we want to do is onDrawGizmos, we want to measure the stuff. Meanwhile, we are changing values. There's also later on another function I'm gonna show you, which is kind of the same as onDrawGizmos, but different. And that's what we want to do. Soon. Okay, so what we want to do at first is we want to calculate the distance. So we want to have the distance between the two arrows. So we set the distance equal to vector3 dot, and then we take this function, which is called distance already, where we can place in a vector A and a vector B. And those vectors are just going to be calculated and return a float in the end. And this float is going to be the distance between those 2 points or 2 vectors. And what we want to do is we take arrow L dot transform dot position, and this is going to be the first vector, and we want to take the other arrow, so the arrow R dot transform dot position. So now we have filled in the complete distance by measuring it with the distance formula over here and put this into this distance. Now we want to draw the text, or we want to draw the distance inside the text field. So we say text field dot text. Since we need to put in a string, we need to convert stuff here. It is going to be distance dot, then we convert it to string. And in open close parentheses, we can also say what kind of format do we want. We want to have a number with 2 endings. So it's going to be rounded up a bit, like up to 2 comma numbers after the comma, basically. And then we add a plus, and in 2 quotes, once again, we put an M for meter. You can also calculate this one, all of that stuff down, and take centimeters, or you can calculate it times 2.56, I guess, to get inch. That's up to you. So the next one is, well, let's first test this out. So before we can measure things, we're going to get a dozen null references over here. As you can see, the text, the fields, and everything is already over here. So, but since we have a null reference, means we are missing something. And that missing something is we need arrow left and arrow right as tool. So we put in arrow L in here and arrow R into the other one. So when we are clearing the console, basically everything is fine, but we don't have a text field. So we need to take the text and put this into the text field. So when we now do anything or scroll around and stuff like that, we shouldn't have any problems at all. So when I now take this little arrow in here and move it side by side, you can see the distance gets automatically measured and written inside the text field. So, and that's cool. So we already have half of everything, or actually you can already start to measure things with that. What I want to make this tool a bit more complete. So I give it a bit more possibilities. So I don't need to fiddle around with the scale on here. So I give it a specific scale range, for example. And also I want to have a connection to that if I am able to. basically do all of that things and all the calculations. So usually we need to put in everything to make sure everything works fine. We need to put in everything into several different if statements. And also we want to make sure that the canvas sits in between both arrows. And for that, we're going to create another function. I'm going to start with that, since that is going to be the biggest problem, I would say, over here. Meaning we create a not of type void, but we create a function of type vector3. And I call this lerp by distance. And in open close parentheses, we're going to put in 3 arguments. We need a vector3, I call it A. We take another vector3, I call it B. And we need a float, and I call this one X. The float X stands for the time or the distance in percent, well, between those 2 points. So we are lerping between 2 points by a specific amount in percent. So what we're going to do is we're going to create a new formula over here. So we create a new vector3. I call it P for position. This is going to be representing a specific position between those 2 points, like between vector A and vector B. And the formula is rather simple. So we say A plus X times, open close parentheses, B minus A. And how does that formula works is pretty simple. This is the starting point, and we add a percentage of type float to the starting point. Then we multiply that point by the distance between the vector B and A. When we say we calculate vector B minus vector A, we still have a distance. It's basically the same as this function over here. But what we want to do is we want to add this little x over here to the start position related to the complete length of the distance. Okay, I hope you got that. So what we now want to do is we want to return P. P is going to be the position vector of where our canvas has to be. So what we now need to do is to position the canvas directly between those. We need to call this particular lerp by distance function. How can we do that? It's pretty simple. We set our canvas dot transform dot position. We place that within or with the use of the lerp by distance. So we say lerp by distance. Now we put in vector A, B, and the time value where we want to have that. So once again, this float number in here needs to be somewhere between 0 and 1. That means any number in between is going to be 0 to 1 means 0 to 100%. Okay, so how do we do that now? We say we want to position the canvas between arrow L dot transform dot position, comma, we want to position it between the arrow R dot transform dot position, and now we need to put in any float X. In this case, 0.5f. This is 50% in between. And of course, the semicolon needs to be outside of this parenthesis. Now, when we have done that, we need to add the canvas into the canvas slot. Otherwise, once again, we get an unassigned reference or a null reference. So we take the canvas and put it in here. And now when we are moving around any arrow, the canvas always stays in between those 2 points or those 2 arrows. And that means it also drives the text field automatically. So it will be always in the center between the arrows. And this is happening independently from the measure tool position in the center as well. Okay, and that's cool. That's nice. So what we now need to do is we need to make sure that we can use some sliders to increase and decrease arrow size and text size. And we can do the same stuff also in the measure my stuff function over here. How do we do that? We go maybe like 2 lines deeper. And what I want to do is I want to do some checks first. So if arrow L is not equal to null. So if that is representing, or if it is there, only then we want to do the change. And the change is what we want to do is at first we want to say arrow L dot, and now we want to get its component. And the component we're gonna talk to is the sprite renderer component. You can always check that out. Sprite renderer. And the sprite renderer contains a color, as you probably already have seen. And we want to set this color to be the arrow color. That's it. Next one is we want to change the local scale of the arrow. So we say arrow L dot transform dot local scale, and we want to set this one to be the value we set into our scale value, in our arrow scale value on all three axes. How do we do that? We say we create a new vector 3, and in open close parentheses we say arrow scale this, comma, and then we just copy and paste for z, x, y, and z the same value like this. So now we can scale it down by numbers, and now we want to rotate it by the rotation angle. So we can say arrow angle, or no, in this case it's once again arrow L dot transform dot, and in this case we're gonna take the rotation, but the local rotation, and we set this one equal to, and now we create a new quaternion dot Euler. And this Euler takes vectors, and we can now put in anything we like to. So we just put in an x, y, and z coordinate or value. In this case, we take the x value. In this case, for the arrow, what did I named it? Angle, comma, 0, comma, 0, comma, 0. That means we feed in onto the x-axis and quaternion local rotation between 0 and 90 degrees later on onto the x-axis of our arrow. If you have done everything correct, it is going to be the arrow, the x-axis, otherwise it might be another axis, so make sure you create it correctly. So, and that's what we're gonna do for arrow L, and of course we will also want to make sure that we do this for arrow right, for arrow R. So we need to change all these L's in here to be R's, because they are making use of the same stuff. Let's test it out. I save my script, and this should turn invisible or black. If it is invisible, I'm gonna tell you why. Because when you create a new color field by code, this alpha value is set to be 0. We need to make sure that this alpha value is set to be 255. Same for the text value. This one has to be 255, otherwise later on you don't see the text when you are going to colorize this text field. And talking about the text field, we're gonna put the text field in here as well. So we say if text field is not equal to null, so there is a text field inside. Then we put the text field dot, and now we can take the color directly in here since we already implemented this. It's going to be equal to text color. And what we want to do is we want to change the scale of the text by a specific number as well. So we say text field dot transform dot, once again the local scale is going to be equal to a new vector 3. We can also, I believe, take a vector 2, but let's make it nice and simple. And we want to take the text scale, comma, text scale, comma 0, since z is not basically not affected by that. Don't forget to end the line with the semicolon, and let's test it out. So what we now should be able to do is when we clear the console and everything is fine and the compiler has run, we can simply take these little numbers in here and put the scale of our arrows between left and right. So you can see you can basically bring them outside or inside if you like to. We can also do the same with the scale of the text. We can put this big and small and whatever and so on. But as you can see, it's not easy to set up. And that's what I want to implement this sliders, this range sliders I have shown you. Oh, by the way, we can also check this little angle in here for our arrows. So as you can see, they are now lying almost flat on the ground, as I showed you in the preview as well. Okay, so going back up, and we want now to say we want to change the arrow scale by a slider. And also we can group things, basically grouping them by a header. So that's what we'll create at first, a header, open close parentheses, and in quotes we can give the header a name. It's everything about arrows. So when you create tools, you want to make sure that everything has a specific field and stuff like that. So here I'm gonna place another one. This is going to be everything about text. And the canvas is, yeah, basically we can keep it as is, but when we want to, we can also say we want to put something for the canvas in here. So everything about text is going to be here, everything about arrows is going to be here, and the rest is going to be here. Okay, that's good. So the next one is we want to put this little range parameters. So we open close that square brackets once again, range, open close parentheses, and now we can set a minimum and a maximum. So we can, for example, do it like 1.5 f comma 0.15 f, but the first one can be a negative number if you want to have outside or from inside to outside arrows, or you can also increase this values bigger and smaller as you like in place by this arrange thing. So we can do the same for the arrow angle. So I want to have another range parameter over here. The range should go between 0, 90. So between an angle of 90 degrees or 0 degrees. Then the arrow color does not need any range parameter or something like that. The text field doesn't need anything, but here the text scale, we want to have a range parameter for the scale as well. So we can put in stuff like, once again, range and an open close parentheses, something between 0, comma, and now we maybe do something like 0.2 or 0.3, like 0.03 f, stuff like that. And we're gonna save the script and return back to Unity. Let the compiler run everything, and we should be able to see those sliders now. So I can see I can do the slider and do the rotation on the x-axis. I can put the arrow scale down and also into the negative direction when I want them to point inwards. And also we can put the text scale now to a maximum of 0.03, maybe a bit too small. Maybe we want to give it a bit more range, maybe a maximum of 0.1 over here. So meaning when we take the slider here, we're gonna have a bit more space to put that stuff together. So what can we do now with that cool tool is we can create 3D objects. Let's say a cube. A cube has a scale of 1, 1, 1. And if you always wanted to know how big is one side of a cube, we can make use of our new measure tool. So we drag it a bit to the side as close as possible, and we take our arrow left over here and we bring this one in a best way to the isometric view. We're gonna bring this to the outer corner. Same for the other side. We could just take the arrow right. Somehow I'm not 1% isometric, now I am. And as you can see, this number or this side is 1 meter long. When the text is too big, we can just reduce it, as well as we can do with the arrow scale. We can bring it down a bit more. So this way you can represent now every tool and every stuff you like and please. Once again, you can also take the arrow scale inwards like this, and you're gonna say or show the same way, since the pivot point once again is on the spike of the arrow. One small last note is when you are starting to measuring to a thing, then here, as you can see currently, I have set them up to 1 meter, 2 meter, and 3 meters, and I also created a prefab out of them just by dragging one of these measure tools or our base measure tool into here. But the problem is when I now press play, I'm gonna show you that everything is to be on 1 meter, 1 meter, 1 meter, even if it is not the case. So what do we need to do is we need to create another little function over here I mentioned before. It is called void on validate. So whenever we validate the data based on whatever we have put it into the inspector, we need to validate and update basically everything inside. So we want to measure stuff. over here into onValidate function. So when the compiler is completely done and we now press play, everything is already set it up correctly. So you see, this one is 3 meters, this one is 2 meters, this one is 1 meter. Pretty nice, pretty simple, and that's it. If you have any questions, feel free to ask me in the comments below, as well as write me a message if you have to or want to. I try to put this one onto my website for a small fee, so you don't have to do all the work if you don't like to. And you can purchase this one, I guess, sooner or later on the website as well as some other useful tools and tutorial things. Just check it out. It's in the description below. Thanks a lot for watching, and see you soon or in another tutorial. Bye bye. Thanks for watching the tutorial. I hope you enjoyed it. Don't forget to subscribe to my channel if you haven't already. Thumb this video up if you like it, and feel free to become my patron or donate by using PayPal to support me and my channel in the future. All links will be below in the description. See you in the next tutorial. Bye bye.